Just a quick little hangout about a picture of the moon that I've had, one that I took last summer that I've had as my desktop background. And I was just looking at that and going, you know what? There's this question of the moon's shape. And the question is it a ball, a sphere, or is it a flat disk, or is it a concave dish? And aside from actually going there and looking and getting outside of our atmosphere, we know enough about optics and cameras and telescopes and light, the physics of light, to tell us, at least rule out some things. One is look at how sharp the foreground focus is. And my machine is quite laggy. I'm trying to look into ways of improving that, but I have my mouse running down here at the lower left at this ridge. I believe those are the Appian Mountains or something like that, named after some place in Italy, I understand. Nice sharp edges on things for the most part. That's where I was focused. If you get out toward the edge, things get blurrier. Okay, it might not be as obvious on the watch page video there, but it is on my screen, and this is somewhat blown up. On the original size is quite large, so this was a smaller picture in my picture viewer to begin with, so I blew it up a little bit just so you can see the difference, and it's still probably hard to see, but it's nice and sharp right here by this mountain range, and it gets blurrier as you get away. What does that tell you? If you know anything about light, or especially photography, you know something called depth of field. The more you zoom on something, whether it's macro or micro, the shallower the depth of field, meaning a narrower range at which the distance will be in focus. Okay, the objective, whatever you're looking at. For example, if you want to take a macro picture of a flower and you want the background to be blurred out, you can do that in post-processing, but you can also do it right there when you take a picture by using a macro lens, focusing at a very short distance. That will cause everything around the center where you're focusing to be blurry. And that's a shallow depth of field. And the same thing is true at the other end of the zoom scale where you're going far away. And that's the case with the moon. Of course, with the P900, that even that with the 83 times zoom was not at its maximum zoom when I take pictures of the moon. It is a little bit short of that, but not infinity. At infinity, pretty much everything is the same focus. The depth of field is pretty deep because you're not tightly zoomed. But if you do zoom in, as I did for just a part of the moon rather than the whole sky, if you shoot infinity, you generally aren't zoomed. If your focus is in infinity, if you have, a couple other different settings on your camera. But if you zoom in on something tight, like I said, it's going to be a narrow depth of field. Okay, but even at infinity, that still doesn't mean, if I might have said that in a confusing way before, infinity doesn't mean everything's the same focus. It just means how far you're zoomed. So I might have got ahead of myself there. Sorry about that. So this is where I was focused, more in the middle, because part of the picture is off the screen here. And then as you get toward the end, sorry about those artifacts on my cursor. That's a problem I'm having with my computer. It gets blurry, okay? And that blurriness is telling me that the moon is not flat, okay? If you zoom real tight on something and the center of it's sharp and the edges are not, they're at a different distance. That's what I'm trying to say with all that bit about depth of field. It's a different distance. Now then, so we can rule out the moon being a flat disk. But is it curving away or curving toward? The problem with curving toward, that is to say a dish or concave moon, is that you would expect the opposite side of the moon to be lit. In other words, since the sun allegedly, if the sun is lighting the moon, we don't know that for sure, but if something, we can see that the light is coming from the right to the left because of these shadows on all the craters in the mountain range and everything. All the shadows are on the side where the light's coming from, and the opposite ridge is lighter. That's what light does. If you take a golf ball or some other irregular surface on a ball and shine a flashlight on it, you will see the same thing. You will see shadows on the side toward the light, where the light is coming from, and the opposite side of these indentations or raised up portions like this mountain range. An indented one will have the brighter side on the opposite edge because the light is not hitting in here, and it is hitting that edge. With these things, they're up, and so they're blocking the light, so they have a shadow on the opposite side. Everybody knows that's how light works. Okay, so the light is coming from the right side of the picture to the left. Okay, if that's the case, whatever the source of the light, it's coming from the right. If the moon were a dish, then this side would be dark, just as this, think of this as a mini model of a dish. I mean, it's indented, right? When light comes from this side, the side the light's coming from is dark. The other side is light. But because we also on the moon have these raised portions, we know that the light must be coming from this side, from the right. If it were a dish, it would be lit up on the left side. Okay. So because we have both indentations and raised up portions, and they're all consistent with light coming from the right, then if this were a dish, the brightest portion would be on the left side, but it isn't. So I am forced by the laws of physics and the known properties of light, the observable properties of light, to say that the moon is a sphere. Okay, this is just science. This is not what I want the moon to be. I don't care. I want to know the truth, whatever it is. Now, of course, this doesn't mean anything about any other shapes of any other objects, especially the Earth we're standing on. Because you can't look at the sky and figure out what shape the Earth is. So all I'm saying is that the moon appears to be, because of this photo and many others, appears to be a sphere. Whether it's solid or not, whether it's real or not, whether it has strange properties of refraction and reflection, those are different questions. The point I'm making is that because of the way the light looks in this photo and the fact that we have a depth of field, and that by both the indentations in the craters and the raised up portions of these mountain ranges, we have a consistent right-hand light source telling us that this is not, the whole thing is not a dish. It's not concave. It is convex. It's a ball, a sphere. This is the moon only. Okay. Other objects in the sky, I can't say. There is no depth to speak of on the sun, unless you consider the fact that the center portion is brighter than the edges. I've seen this myself with solar filters on my camera and or telescope. So it too could appear to be spherical. Here again, it's very unlikely that it's a dish, a concave thing. The rest of the sky bodies, the points of lights that are stars and the alleged planets, which means, from a Greek word that means wanderer, they are the wandering stars, the stars that move and don't stay in constellations. Those would be what we call the planets, but they are pretty hard to get depth out of those. And here again, we don't know by optics alone whether they're small and near or large and far away. We cannot tell. We don't have enough hard data. But what I am saying, though, on this quick little hangout is that because of the sharp focus toward the center of the photo, the blurriness at the edge, we know the moon has depth. And because of both the raised mountain ranges, shadows, and the indented crater shadows and the light on the opposite side. We know the light in this picture is coming from the right, going to the left, and therefore it cannot be a concave dish. So I have to say, all things considered, that the moon must be spherical. Whatever else it is, I don't know. And what anything else is, I don't know. I'm just saying this about the moon. So I guess that's really all I had to say today. Mostly I'm going to be on Steemit and DTube. I'm moving over to that. I'll leave this stuff up. And I'm doing this video here because I really just got started with DTube and Steemit. So I thought I would put this here, and maybe someday I'll put it on Steemit. I don't know. But I'm thinking I'm not going to put Hangouts on another platform. That just kind of doesn't seem to fit. Anyway, put in comments later about what you think of the rationale that I'm using here on optics and light and all the properties of the whole photo. I guess I could, let me see, unzoom this somewhat so you can see there's the whole picture. You can see also the dark part. In some photos, it looks for all the world like there's just nothing there. And if you enhance the photo in Photoshop or GIMP or something, it still looks like there's nothing there. But you can see, you can follow this range, follow the artifacts on my silly mouse. It still continues into the dark here because there are higher portions that a bit of the light can hit. Okay. Same over here is a little bit of a crater, some little spots here. I don't know if you can see on the screen. And so clearly the moon, these other portions in the dark are there. The moon isn't disappearing. Okay. And so here again, this was more the center of focus. And I might add that if you use the automatic moon setting on the P900, it is very sharp in the center. It's meant to be sharp in the center. And the whole moon will look sharp if you have the whole moon in your viewfinder, which is what the moon setting does. But then what I do is zoom in after it sets that. Okay, so it's not changing its focus when I zoom in. Okay, so it did its, let me see if I can get rid of some of those. I guess I can't. When I did the automatic moon setting, it sets for the moon filling the frame, and it's all, the whole thing is in focus then. So this part in the center is what it's going to be weighted on, and it's nice and sharp. But then, like I said, if you zoom in, this is only a small portion of its actual size. And then I move up like this. We can see that these portions are nice and sharp still. That edge is not. And these things look, these circles get more elliptical as you go toward the edge. That's typical of if you draw a circle on the surface of a moon or on the surface of a ball, and turn the ball away from you so that the circle is toward the edge, it's going to look more elliptical. That's what it does. So once again, if you just got here, I'm talking about depth of field in this photo that I took last summer, and the fact that on the automatic moon settings on the P900, you get the whole moon in the frame and the whole thing is sharp. And then I zoomed in when I took the picture. After it made those settings, I zoomed some more, which does not change the focus. And the center, these parts here, which are more toward the center, let me back out again and show you where things are. Like I said, when the P900 focused, it focused on the whole moon, and it's weighted toward the center. So this stuff is going to be nice and sharp, more toward the middle. Okay. But then I manually zoomed in, not on manual settings, but you can change the zoom even after it picks the moon scene setting. Okay. And I didn't change anything but the magnification. And then now, this is a small portion of, that's the whole picture, but it's smaller because it's fitting in my picture viewer. Well, now if I zoom in a bit, I still don't think I'm at 100%. That's when I was showing you this picture and how these things, by their properties, are showing you the light's coming from the right. And because we have both raised mountain ranges and indented craters, it's consistent with light coming from the right. And because it's brighter on the side where the light's coming from, it is not a disk. It is It's not concave, it is convex. And as you go away from here, things get blurrier, which means the moon has depth. That's depth of field. And we're very zoomed in, not to infinity, but very zoomed in. And therefore, you have a shallow depth of field. I think I can still zoom in some more. And I have to be careful to use the scroll bars instead of just the mouse wheel, because otherwise it will try to go to the next picture. And then it gets a little blurry. You zoom in too much, it's going to get blurrier anyway, but it's not as blurry as the edge. So that's the point there. Also, while I've got this zoomed in, see the raised dot, raised dot, raised dot in the middle. That's a lot to do with, this is something that can be duplicated in a lab regarding electrical arcing, and especially in a plasma field, I understand. And these are all very shallow, especially for their size. They are not impact craters at all. I don't think any of them are impact craters. And they are not, there's no debris, there's no pit in the middle or anything like that. And so these probably happened when the moon formed, or as the aftermath of the Great Flood. A lot of things went bad during that time. So we can't say why the moon has the features it does. Well, we also know that some parts are much more reflective than others. You can't say there's suddenly a big spot that isn't as well lit. I mean, the light goes gradually to dark. And so therefore, this is more reflective, whatever this stuff is. More like snow almost, and this being like a black ice lake, black ice being transparent ice. And you can also see a streak that goes all the way across the frame here. Okay, it's always there on the moon. And by the way, I have pictures of an astronomy book from the 60s that show the moon's features essentially what they are today, maybe a slightly less resolution, but there they are. So the moon has not changed, at least since the 60s. And we have things like these streaks that go as far as it could be going past the rim there around the edge. And there are other streaks too on the Tycho crater and the Copernican crater on the other opposite corner, also have long streaks on them. And so, and we have some streaks here. This could indicate arcing. It could indicate, I'm going to say just, how it formed, because certain materials will bubble like this, bubble and pop. These look more like popped bubbles, a lot of them. They're certainly not impact craters. Question in the chat, or a statement in the chat about the P900 moon settings. I don't think they're trying to hide anything, because what I did this last summer also looking at the sun is I used the moon setting. For all the P900 knew, I was looking at the moon, okay? But I pointed it at the sun instead and got the same result as far as the size of the sun, maybe slightly different, but not much. I mean, the whole sun fits in the frame. It thinks it's looking at the moon. Okay, so, and it's nicely sharp and focused around the edges. Of course, there's not much in the middle to focus on, except if there are spots. And I've done that too. You can see on my cosmology playlist, which I will add this to. And so the problem is that the P900, although it is programmed, I can also cross-check it with my telescope. Okay, which is purely optical. I bought it decades ago. And there's nothing electronic in it except the motorized mount, which doesn't know where it is until you tell it, because even if you use the motorized mount to track things, you still have to A, point it true north, which is toward Polaris, B, make sure it's absolutely level, and then C, line it up with two known fixed bright stars in the sky. Okay, if you don't do those things, it will not track what you're looking for. So it doesn't have any magic in it telling you, putting stuff on the frames that isn't there, putting fake images in the frame. It's just not doing it. The telescope is purely optical, and its electronics are not that smart. Okay, otherwise I wouldn't have had so much difficulty using the thing to track objects, to find them and track them. So, I can compare those results with the P900, and they are identical. So the P900, in my opinion, is not doing anything to fool anybody or hide anything because it doesn't know where you're looking. Okay. And I can guarantee you, if you take apart the scope, you will find no electronics in there. And if you think there's something there that is too small to see or is well hidden, that is an argument from silence, and that is something you would have to prove. You would have the burden of proof for. Until I see such evidence in my telescope, I'm not going to entertain the idea that there's something fishy going on. But because you can make your own telescope. You can get some lenses, you can grind them yourself if you're that paranoid, and make your own telescope. Okay, there's plenty of instructions how to do that. And yes, it is purely optical. If you especially get your own grind your own lenses, there are books on how to do that. You will get the same results. You can put, an ordinary magnifying glass, a set of them from your house, take them out of their little holders and put them in a cardboard tube if you know what you're doing with the distance and the shape of the lenses, and make your own telescope, and you'll get the same results. And so this is no trickery that I'm aware of. The charge of trickery needs to be proved by those who make it. And in my opinion, as I've said, I've compared this, what the P900 sees, with what my telescope sees, and not just one telescope. I have others that aren't as high magnification, but they tell me the same thing. There's nothing fishy going on. And like I said, the P900 doesn't know what I'm looking at. It only knows what setting I chose. It doesn't know if I'm looking at the moon or the sun or the stars or a mountain range in the distance or anything like that. It doesn't know what I'm looking at. If it did, it would track things for me, which would be awfully nice, but it doesn't do that. You have to buy a separate motorized mount to track things for you. And even then, you still have to set the thing north and level. And because if you don't do that, if you just set it on a table and tell it track my stuff, it won't be able to do it because it doesn't know where you are. It doesn't know which way you're pointed. It doesn't know what you're looking for, because you don't say, find me the moon. You just say, here, it just has settings that say these are optimum for putting the moon in the whole frame. That's all it knows. Like I said, I proved this by looking at the sun with it. It didn't have to change a thing. So as far as it's concerned, the sun and the moon are the same distance because it doesn't know I'm looking at the sun. And yet the moon settings work for that. So yeah, if you get out a nice telescope, you make yourself, grind your own lenses, get your own plastic tubes or whatever you want. You could use PVC and whatever, and do your calculations and your lens shapes and get something similar to this magnification. You're going to see this. And let me know when you're done with your experiment with your homemade telescope and see what results you get. If you see cities and technologies there, then I might believe you as far as whether the P900 or the telescopes are trying to fool us. I think, again, the burden of proof lies on those who make the charge that these things are monkeying with what we're seeing. And I don't think they are. But here again, that's not my point to prove because I don't make that argument. I'm thinking they're legit. As far as a major telescope like the Los Alamos or the Lucifer or any of those big funded billion-dollar projects, they're probably seeing accurately, but they're not going to tell us what they're seeing. They're not going to show us the pictures, not without doctoring them. That's where the shenanigans come in, is when somebody says, this is a picture I took with my fancy billion-dollar taxpayer-funded telescope. Then you can say, yeah, you probably faked that. But when it's my own stuff that I took, no. So anyway, that's all I wanted to say today. I will add this to my cosmology playlist, but the point, once again, is we see evidence here in this picture of depth of field. The moon is not flat. And by the shadows on the mountain range and the indentations of the craters, we know that this is spherical, not concave. And that's all the point I wanted to make today. Thanks for watching. See y'all later if I can just find where the window is with the off button. There we go. See y'all later.